Hello, friends. Good morning and good afternoon, and welcome to the Eastern Academy. And we are into the discussion of understanding 8085. And now we are into the week one, day one, and session two. And if you have any doubts, you can contact me at my WhatsApp number and or by mail. That's a thing we have it. And we are discussing about 8085 pinouts. That's normally whenever you take a processor. People always go by architecture, but since we know about microprocessor, and we are going to discuss about the pinouts, and 8085 has about 40 pins, and out of 40 pins, we have discussed about A0 to AD0 to AD7. Why it's called AD, we have discussed, and we discussed about A8 to A15. That's only address line, where this is multiplex, and we discussed about PCC and BSS, that is the power supply pins, 2 pins. And we discussed about 2 pins for crystal input for clock, and then read bar and write bar in the ALE. And we also discussed about why we put the bar. It means that active, low. And here we have a reset in bar. That means that when the reset pin is 0 volt, then the 8085 gets reset. When the reset pin is 5 volt, it does not do that. So we are trying to generically compare with a generic microprocessor with our 8085A or 8085. What are the differences we are looking at thing? Now let us continue our discussion, and for that let us go back to the board. Okay, so let me make the video off. It was very good actually. So this is what the general. Normally there was something with a general microprocessor. In general microprocessor, we don't have a signal called reset out. This is not this, because the reset circuit itself will do it for the reset. So generically, microprocessors don't have reset out, but 8085 was designed in 1976. 1976. That time they thought that let us give a reset out. And this is called reset in bar. But this is active high. This is active low. So out of 16 pin, we have another signal called reset out. Also, they had one more signal called whatever they from the crystal they generate. I told you general microprocessor clock is the input, but here you have a X1 and X2. You are connecting a crystal. And inside there is a crystal oscillator. The clock out is going out. But unfortunately, this is a very old processor in 1976. You cannot imagine the speed. The speed at which it is operating was 3 megahertz. Today you are operating at 3 gigahertz. That is 1,000 times faster. Then when they put increased power, AH and all, they gone up to 5 megahertz. Then they gone up to 8 megahertz. Forget about that. Let us assume that 3 megahertz and operate on that. That'll be easy for us. That's another variation. Now, forget about that. Clock out. Also, we discussed that the microprocessors has a signal called address and data. That's what, but all latest microprocessor only that is address and data. And they also demultiplex, not like your 8051 AD and A, sorry, A and AD. No, it's not there. Nowadays it's only A and D. But we also discuss for some of the classes, in some I have not discussed. These microprocessor manufacturers, especially Intel, initial days. There's other guy, equivalent guy was Motorola. They were the actually competitors in 1960s, 70s. There were two people. Now, what happened was, this Intel thought, when I'm writing into the memory, there are two types of memory. Both are memory only. There are two types of memory. One is called RAM and ROM. We call them as a memory. But second one is called IO. That is your keypad, LEDs. All those things are called IOs. So what Intel thought, let us have two address space. There is a big confusion all the time, people. Two address space. One address space is for memory, ROM and RAM. Other address space for IO. But today we don't have it. This is a generic microprocessor. Everything is same. Memory and storage. Yeah, there are a lot of confusion. Okay. Memory is generally temporary and fast, costly. That is what we call memory. Memory will be talking to the microprocessor directly. Microprocessor, see, this is, I'll explain later since somebody has asked. I said that you have a microprocessor and they have a memory, RAM and ROM. They talk to microprocessor directly. Okay, they are fast. They are costly. They are small capacity. And they are generally temporary. Even though ROM is a permanent, but we don't use the ROM for generally, it's only a startup program. We don't use for permanent storage. It's only for boot up. So these are the features of memory. But storage does not talk to microprocessor directly. There's a microprocessor and there is somebody, then I have a storage. It could be your hard disk. It could be your CD drive or USB drive or your SSD. Whatever could be your storage. In between, there's something called controllers. Through controller only, I can go to storage. So memory is talking to. Yeah, that we will discuss. We have, I think you are getting into the system first. So we will discuss in other paper. We will discuss as a part of the embedded system programming ROM and RAM. Okay, that we discuss actually for people. Yeah, same ROM. No, yeah, it's different. Actually, when I say storage, your hard disk, which is magnetic and not are coming into the thing. Okay, now, what is the difference here? This is slow. Storage is slow, cheap, whereas your memory is fast and costly. And your memory is small in size and your storage is huge in size. And Your memory can talk directly to microprocessor. Your storage goes via controllers. There are so many differences. These things are called storage. Your cache is faster than your RAM and ROM. That is a RAM. Your cache memory is a RAM. The RAM, see, I told you that, see here, you see here. There are, I think I can explain a little bit, don't mistake, because this session can go faster. I can take 1 or 2 days extra, doesn't matter. But I'll explain the top level. We are going to in-depth explain about all these things in our embedded system programming class. But now I'm giving you a top level since somebody is asking. A ROM and storage. What is cache? Cache is nothing but a RAM. I told you that RAM is a memory. The read-write memory. It's a RAM. In the RAM, there are 2 types. One is called DRAM and SRAM. The DRAM is called cheap. That's why all your computers, mobile phone, you say that I have a 2 GB RAM. That RAM is this DRAM. But this is slow. Whereas SRAM is costly, but it is fast. The RAM itself, there are two types. The SRAM itself, there are multiple types. Fast SRAM, fastest SRAM. Now we use SRAM as a cache, DRAM as a main memory. Okay, let us discuss this in our embedded system class. Somebody has started a very small question as storage and main. It goes direction somewhere. Let us not get into the thing. Now let us get into the thing. Our general microprocessors, okay, has address, data, read, and write. If my address is 6 lines, I can access the memory of 2 power 6. That is 0002 111. That is what the address line means. Okay. If your address line is 8, I can go from 00 to 11. That means that your microprocessor will have one memory space, but Intel thought they're going to get one more address space. But how do you decide whether this address belongs to here or here? For that, they're given a one more signal called IO. There's one more signal called IO. If IO pin is 0 volt, then that time they are accessing this memory. When it is 5 volt, they are accessing the IO. Okay. Now, that's why they call this signal as a IO bar membar. IO is enough. They put membar. That means that, see that memory bar. That means that when it is 0, it accesses memory. When it is 1, it accesses IO. So now I got 2 spaces. That means that Intel has 2 set of instructions. One is memory instruction. Other one is IO instruction. Okay, let us call this a store and load. Store and load means memory instruction. In and out means that IO instruction. So we will discuss this in the next class when I'm discussing about instructions. We will discuss about all the 247 instructions of 8085. We are not going to leave it. I'm not going to assume you everything. We will discuss about all the 247 instructions of 8085. how exactly that instructions are working. Okay, how this guy is, when the moment you power on the microprocessor, how exactly the 8085 starts, how do you write a program? We'll do everything. Don't worry about that. So there is one more signal called IO member, which is there in your 8085 for that. And there is another trick in the microprocessors, all the microprocessors. I write a program, let us say I write a C program. Car, or let's say int itself, because people like that confused. Int ABC. A is equal to 10. B is equal to 20. C is equal to A plus B. I write a small program. Am I right? This program itself is there in the memory. The program is, the moment I compile the program, because this guy language is machine language. The moment I compile it, I'll get something 0, 5, 10, 0, 6, something. I'll get full of numbers which nobody understand. That's what we call this as a binary file. That's what we think is a binary file. Now what we do, this binary file is put into the RAM. That's what the process you're calling it as a flashing. This is called compiling. That is translating. You write in a C, from C you convert it to machine language. Then the machine language you get as a binary file. Then this is called source file. Or this is called object file. All are same. Binary object is same. This object file means it is for the object microprocessor. That's why they made it in English. Now source file is your file. You created. You can understand. If anybody can read this, they understand. If somebody read this, they don't understand. That's why you cannot understand the compiled file. But other way, microprocessor cannot understand source file. The microprocessor understand only the compiled file, binary file. So understand the difference between microprocessor and the yourself. Okay, you can understand source file, you cannot understand binary file. Microprocessor cannot understand source file, microprocessor understand binary file. Now the trick here is, this was the trick. The whole instruction is there inside the memory. This one, 0, 5, 10, 0, 6, whatever it is. I write the whole binary file into the flash. The moment you give a power to the microprocessor, he reads from the memory and executes. That means that he is executing the instruction. So the instructions are available in the memory. That is called command. You may call command or instruction. They do a small word change. When I'm reading the instruction, but same way here, you have a B, C. These are all called variables. This is called data. This is stored somewhere. A, B, and C. You put 10, 20, 10 plus 20, 30. You have it. This is called data. This is called instruction. Both are stored in the memory. But instruction you cannot write because the microprocessor is a slave. Please understand, microprocessor is a slave. He acts as per your instruction. So the microprocessor is a master, not a master. Microprocessor is slave. You are the one who has written the source file. You have compiled it into the binary file and you store the binary file here. All done by you. So you are the master. Microprocessor job is to follow the instruction. So microprocessor can only read the instruction. It cannot write the instruction. He is a slave. So that time, what we say that reading the instruction is called in the industry fetching instruction. Fetching instruction. We use the word called fetch. Okay, I can call this a reading instruction, but industry is calling the word called fetching, because when I say fetch, I can call it the instruction fetch. Don't confuse between instruction fetch and variable write and read. When I do variable, I write called data read and write. I do data read and write. When I do compilation, I do that. So there are two operations, fetching and reading. But see here, the most important thing. The most important thing here. The microprocessor gives address. It gives read signal. Am I right? But how do I know that? Let us say somebody outside, they thought, not now. Nowadays, not. In 1976, Intel thought, how do I know that whether he is going to fetch or he is going to read or write? For that, they given two pins called S0 and S1. That is called status pins. You get four combination. You get four combination. Okay. The four combinations are all. One is I am doing fetching. Other combination is I am doing read data. This also read data, but it's called fetch. Other one is I do write data. Other one is I'm doing halt. That means that I'm not doing anything. I'm halted. That means that if it is 0, 0, I'm halted. That means that I'm idle. I'm not doing anything. Please understand, there is a stage in 8085. There's a 8085. There is a mechanism by which you can put the processor into the halt mode. If you wanted to wake up, you give either reset or you give an interrupt. Only two methods you can wake up the processor. Otherwise, the processor go to the halt mode. Okay, that is told by these two pins, status 0, S0, S1. Okay, now you understand what is the use of, but you don't have any use. That is given, Intel has given, and it's not fairly used by anybody. It's not at all used by anybody much. They thought somebody will be using it. That is since 1976. But latest process, they don't do that. Okay, now, of course, 8086 they have. This is all old. Okay. So out of 16, we decided about 11 pins are over. 5. Remaining is only 11 pins. Now we do 11. I've told you that all the microprocessors in the world has one pin called interrupt. Other pin called interrupt acknowledge. Okay. That means that the little microprocessor stop your activity and give me the priority. I want to have some important activity. Then you say, fine, I have done it. These are two pins. This is normal microprocessor also there, and this is there in your 8085 also. Same way, there are two pins called DMA and DMA request, DMA acknowledge. So we will discuss all these things when we are discussing about 8051 circuit. We will try to do the 8051 based circuit and do circuit analysis. We will take 8055 based circuit diagram, a small development board. We will discuss thoroughly how we are doing it. Then you will understand. Because unfortunately, if you take 8051 and other microprocessor controller, they do everything internally. But which 8051 we give 8085 we can analyze it like this. So these 4 pins are there. But in 8085, they call this as a hold. See, what is the difference between these two? Interrupt means I am telling the microprocessor, stop the current process. Main one. Stop the current process and do this process. Other one. But understand one thing, when I give an interrupt, I am telling the microprocessor, you stop the current activity, do the other activity. So both are done by microprocessor only. But when I have given this guy DMA request, I told the microprocessor, keep quiet, stop, don't do anything. Don't do anything, be idle. And give the memory to me. Then I will use the memory. The one who gives a DMA request, I will use the memory. Then I complete, I'll give you. That means that there's a big difference between these two. Interrupt means I am telling the microprocessor, you don't do the main activity, you do the other activity. There's something important. Do the important activity. Okay. So there's a difference here. So when I give an interrupt, I'm telling the microprocessor, stop the main activity and come show me that I'm doing a main program. I stop wherever it is. I will go to the other main important activity. I will do that. But both are done by microprocessor. He is not going to idle. Whereas when I give a request, DMA request, that time the microprocessor goes to the ideal mode. That means that he is not going to do anything. He is going to keep quiet and giving the memory to somebody else. He will switch off. He will be off from the thing. I'm taking a rest. I'm taking a rest. Then that guy will do the memory, use the memory and complete his all the work. Then he will tell that I have done. I have completed. Okay. Then the microprocessor will take back. That is called, in 8051, they call it as a hold and HLDA. Okay. So now, how much it is? These 4 become 7 pins. Am I right? But though people have thought something a little bit different those days, that's why they have a interrupt which is not generally outside. These guys have a 4 more extra input pins called interrupt pins. RST 5.5. Trap. Okay. What is this? There's no difference between this and this. There's no difference between this and this. But each one will go to different address. Okay. This is was handy when we were designing, but nowadays you don't require that because you have a. We will discuss about something called. Then you will understand this. There's something called 8279 interrupt controller. They were along with the 8085. There are few ICs. 8255, 8253 or 54, 8237, 8259, 8259, sorry, and 8279. These are the ICs which are called controllers. Nowadays, they put all of them inside the single IC and you call it as a microcontroller. That's the thing. Why everybody is asking you to understand about 8085 was you will understand all these things. That's why I thought I'll give you an overview about 4 weekends. Maximum will take about 4-5 weekends. But later we move, once you understand this 8085, we can move on to ARM. Then you will know that what is the difference between 8085 and ARM. So it'll be easy. Instead of directly go to ARM, you go here, you move to 8085. It's simple. All the 247 instructions you can understand. then go to ARM. It will become easy. Okay, so the syllabus is right. In the college, they keep 8085 and 8051. They are all perfect. But the only mistake is those things have to be there in the first semester, not at the fifth or sixth semester. Okay, so now we have about another 4 pins. So it's about now 7. Now these 5 pins are there. That means that, see here, when the microprocessor is executing the instruction, when this becomes 5 volt, it will go to one program. Let's say program 1. And come back. If this gets 5 volt here, then it will go to another program. If you go to 5 volt here, that means that I have 3 functions. Function 1, function 2, function 3. So each one, the only difference is when I call function, you generally do from main. You call function 1, function 2, function 3, you call them. Am I right? But now I am calling these functions. Instead of calling from a main function, I am calling it through hardware. I have 3 switches. Let us assume that I have 3 switches. When I press the switch, it will go here. Understand one thing, that is called interrupt. I execute the software through my hardware signal. Without calling a function through your main function. That is a trick. So this is about 4. 5.5, 6.5, 7.5 and trap. So left out is only 3. Let me see that. I sometimes forget. Okay, so this key had very actually I've enjoyed it when I did the 8085 in the college. Think about 1983. How many years back? About 38 years back. All right. When I used this 8083, I really enjoyed something. Yeah, that's correct. I really enjoyed the 2 signals, actually called SID and the SOD. That is, I have from register, I do bit by 1 by, see, let us say I have a register, a data, I can send 1 by 1 the bits using instruction. There are instructions called, we'll discuss later, RIM and SIM. We'll discuss these things in come to the software. Using the software instruction, I could able to send these 2 data out. That means that this is actually called your RX and TX of your UART. That means that you can make your own UART. We did it. We did all the UART without knowing those things in 83. We communicate between 2 microprocessors. SID, SOD, SOD, SID. So this TX goes to RX, that TX comes to RX, using which we wrote a program in both. Here I write a program, here my friend write a program. So I will do thing, he will do the thing. That's the way we learned it in the that time. No net, no books, okay, no available lecturers, and nobody knows. We are the one, we ourselves dig the details and the data sheet and start doing it. So there were two more pins called SID and SOD. So that vote, only one is left out. That is a very tricky pin, which Intel thought that will be very, very useful for us. That is a wonderful pin. That pin is actually, I told you that microprocessor gives address. Microprocessor gives read or write, whatever it is. And microprocessor, let us take only read. I give address line, let us say address 1000, and I give read as 1, and they get data. The data, how do you know that this guy, memory, you know one thing, there is something called here tricky. I have not used the word so far, I'm using it now. All the memory manufacturers will tell you one important thing, that is called access time. Like you have propagation delay. Delay in your digital logic. There is something called access time. This also generally asked the interviews. These are all terminologies. What is propagation delay? What is access time? What is edge triggered? There were about 10-20 terminology. If you know all the 10-20 terminology, you can pass all the interviews. That's simple. Now, what is access time? That means that you give address, you give read. From that time, how much time he take to give you data? Let us say, if I take that 100 microseconds, it means that I will take this memory, will take 100 microseconds after giving data. But if you accept this data before he give it, okay, then you will accept wrong data. How do you know that device has given you data or not? That's a trick. How do you know that this device has given the data or not? For that, there is a signal called ready. When ready is 1, then only the microprocessor will accept the data. When ready will be there, after 100 microseconds, the ready will be 1. Otherwise, the microprocessor will not accept the data. You know one thing, I have to tell you two words. One is called synchronous, other one is called asynchronous. Okay, this is called asynchronous because you wait for ready. Okay, you wait for ready. But whereas the other one, nowadays, we don't have the ready. I give address, data, read, and I should get data within the time. It's your responsibility to give me, let's say, I accept less than 15 microseconds. You should give it less than 15 microseconds. You should give it to me. No way, I will not wait for you. You should give it to me less than 50 microseconds. That is called synchronous. Today we use all the things are synchronous, but whereas in those days, you are 80-85. See, they tried all the options in 80-85. Even SID, SOD, which is not there in latest microprocessor and all. So these are all typically in 1976. They put out and it was very, very useful. Okay, so ready is for interfacing with the microprocessor with slow memories. Slow memories. Okay, that's very important for us. So now we have all the 40 pins are defined. Okay, this is what nothing. This microprocessor cannot do anything other than this. Not only this, we will discuss the same thing with the latest afterwards ARM processor. That time also we'll take the processor, we'll discuss all the IO pins. Then you will know that they also have the same thing. You take any microprocessor, they have the same pin. Only trick is ALE may not be there, and they may not have this one RST 6.5. They may not have S0, S1, IO bar, but they all have the same concept. Address. This is the basic. All the other things are add-ons. Don't worry about the add-ons and the I have see, if you put it on a group, you will know that a lot of books are there, but I read only one book. I read in the college in 1983, Malvino. Digital computer I read it because this was the only book available for that time, not the other books. That's why we read it. But fortunately, we are very happy. We got even today, even in 2021, if you ask me to refer, I refer this book. But if you ask your friends and colleagues, they were after that, a number of books have come into the market. Today, you have flood of books. You have a lot of free resources. But this is nothing. You don't have to read on books or anything. If you start reading here and there, it's enough. You learn to read how to read the data sheet. Okay, so I feel that 8085 and dot is fine. There are a lot of books are available. You search any book is good book, man. And huge resources available on the net. Huge resource. 8085. We are going to discuss. You read it. Whatever doubts you have, you ask me. We are going to be here on the class. Okay, you can keep on asking me whatever you have a doubt. But why I've taken the pin is that I don't want to get the confusion later. Tomorrow, because from next week onwards, we're going to go to the internal architecture. And all the instruction execution. As I told you that this is important for us because we are going to write a software called assembler. And we're going to write a software called simulator. And we'll be using for testing the programs and everything, we'll be using simulator. I use generally Sim 8085. There are a lot of simulators available in the net. Okay, you can use any simulators and test it out. That's what we're going to use. Because 8085 kits are not there in the market. Also, they are available only in colleges. Outside become too expensive and no use out of money. Flash is a ROM. Flash is a ROM. Oh, Flash and ROM are same. ROM, under ROM, there are two types. Under memory or WM, we call it as a RAM. Other one is ROM. Under ROM, we have ROM, PROM, EPROM, EEPROM, then called Flash. Flash is a type of EEPROM. Flash is a type of EEPROM. Actually, this is called OTP ROM, one-time PROM. This is called UV erasable PROM. This is called electrically erasable PROM, but 1 byte, single byte. Electrically erasable ROM. This is block electrically erasable PROM. Because of block, they call it a flash. So flash is a ROM. That's why you write in a flash, it is permanently there. That's why we don't call it as a writing. We are calling it as a flashing. We will discuss in the class. When you are discussing in the class, we will discuss about what is the difference between flashing and I've not yet explained even both the first batch and second batch. I have not explained how the flashing is taking place, because for that I have to discuss about how the microprocessor is interfacing with the controllers. Maybe next week I will explain about this we are going to discuss from next week onwards. All these things are going to come in. Flashing the ROM, how the UART work, how the SPI and all those things, because we're going to discuss with the microprocessor and controller. For the other batch, we will discuss next. Over every batch, it will come slowly. Those things we will be discussing on the regular ESP program. All these in-depth things. This is only 8085. I wanted you to understand about 8085. That will give you I don't want to mess up this with your regular embedded system programming class. That's why we have started the 8085, a separate session. This will give you the separate track of 8085. This, as I told you, this has a lot of advantage. One is if you are doing the college, second year or third year, it's good for you, the college. If you're going to prepare for the GATE, I think GATE, they have 8085. If it's there, we'll thoroughly. The problem is in digital, you should score 100% mark in GATE. If you don't score 100% in the digital, then you are waste. You should do that, because that is such a easy one in GATE. No, it's not there, because you are only selecting. The microprocessor is selecting the chip select of the device. So microprocessor don't have a pin called chip select. Yeah, it is possible. I did it. 8085, I did not, but not only 8085, I used the entire 8085. They removed the syllabus. Oh God, I didn't know that. I didn't know it was. I think it is there. I know that's a wonderful processor. I don't know why they remove it. If you don't study, you cannot directly go to ARM. Then you will never understand. If you go through 8085, you will understand ARM thoroughly. Not only ARM, every processor you understand thoroughly. I didn't know that. I don't coach for GATE. But what microprocessor they have it instead of 8085? Yeah, if you understand 8085 and 8086 is very easy. Maybe at the end of the last session, after completing 8085, I'll give you the one small session on 8086. Both are almost same. If you know 8085, you'll understand 8086 thoroughly. Oh, computer architecture. Oh, that is same. No difference at all. Both are same. That is fine. So if you have any other doubts on today's 40 pins, let me once again write down all the 40 pins. Please validate if it's right or wrong. I might have forgotten. Address pins, AD bus, 8 pins. AD0 to 7. A8 to A15, 8 pins. Power supply, VCC and VSS is 2 pins. Then clock, X1, X2. You have 2 pins. Okay. You have what else? Read, write, ALE, 3 pins. IOM bar, 1 pin. Then status, S0 and S1, 2 pins. Then you have a interrupt acknowledge, 2 pins. DMA, hold acknowledgement, 2 pins. Then you have an interrupt RST, 5.5. I'll give you everything. Y 5.5, Y 6.5, Y 7.5, Y trap, 4 pins. Then ready. Sorry, very important thing I left out. One is called reset in, out, 2 pins. Clock out, one pin. Ready, one pin. How much? 16 plus 4, 20, 26, 30, 36, 38. There were two more pins. What are the two more pins? Reset in and out. Okay. Yeah, SAD, SOD. I forgot. It's a very important one. Actually, I enjoyed. When I was doing the 8085, I enjoyed the 80, this one. So this was the 40 pins. So if you remember the 40 pins, you can connect anything, understand. That's only about 2 hours. Understand the 40 pins. We will discuss that, how the 40 pins are used when we are doing the circuit analysis or when we are doing the instructions. Every instruction, you know that which pins are used, how they are used. That's it, nothing more than that. But all the pins, except a few, most of the pins are controlled by the software. You can possible to do that 8085. It's available in the market, and you can do it on a breadboard. Actually, we did 8085 using the gates, all 740 gates. We built the 8085 itself. So not the microprocessor. We built the 8085 microprocessor using the gates on a breadboard. I'm talking about in 83, because we don't have any other option. We wanted to learn it. Now you ask me on any doubts here. So I just want to give an idea about the pins. Nothing more than that. You should be thorough with the pins first. Then we will discuss how to use SAD, SOD, how to use clock. Learn it. Then we will do the other process very simple. That's why I took 8085 today. You can also give me hints, because since you people have listened a lot of 8085 talks in the college everywhere, then you know one thing, to be honest, let me be very, very honest. In the college, if anybody has done the 8085 thoroughly with the 8085 assembly language, enough. You are good at embedded, man. You are good at embedded. There's nothing called, beyond which there's something called embedded. Oh, nowadays we have 1,000 and odd pins. 40 pins or so in 1976. Okay, today we have so many pins. We have 1,000, 2,000 pins processor there. Yeah, you can find. It's there. I can give you the thing. We'll discuss the circuit diagram also. We will discuss the circuit diagram also in the thing. No, what I'm talking about is build. There is a software called Logisim. Logisim. This is an open source, free one. It's about old one, but you can build your own microprocessor. That is possible. It's a serial input, serial output. We will discuss. There's a software instruction called Riemann Sim. Using that, we will do that. Okay. It's actually called interrupt mask, but we use that for that. So. Oh, all these memories are physical. There's nothing called virtual here. You cannot do MMU and dot with this guy. That is only for the high-end processor. These are all physical. MMU is, we'll discuss later. When I discuss about ARM, I'll discuss about MMU interface. Not now. 88 is a very simple processor. They tried it on 8086. There's called two modes: real mode and protected mode. But in 8085, there's only one real mode. Okay, so let us stop it. Let me stop the recording.